All attendees are in listen-only mode.
Hey everybody, sorry about that. My computer just hard locked. How are we doing? Are we able to see now? Any luck? Yes? All right. Hey, so it just required my computer to die momentarily, and then we came back. That's good at least. Raise your hand if you cannot see my screen. Uh, Alrighty. I think the cat is eating something it's not supposed to. I'm going to be right back again. Okay, sorry about that. I'm back. Um, all right, so we're probably going to spend the rest of the class doing this challenge then, since originally we were going to do this challenge and then we were going to probably move on to gliding. What took? Oh, so long. Well, you were there for part of it, but my computer just locked up entirely, and so it had to run through and do a diagnostic on starting back up and everything, and it just, yeah, I was super stoked about it. All right, so let me get to lesson 13 here. Oh no, lesson 12. Okay, the end of lesson 12. All right, so the challenge in this case is to design a two-person sport airplane. So the um, requirements are it's going to have to be able to support two passengers, which includes the pilot. So the pilot and then one rider. Um, and well, I guess we'll assume with luggage. You want to have 250 thrust horsepower and an aspect ratio between 6 and 8. And using these things, you want to be able to design an airplane that's flyable and neat and stuff like that, but that conforms to these specs. So it'll require a little bit of review. We can just go through and review it real quick and get that all done, and then I can cut you guys loose so that you can design this airplane. So as far as designing airplanes is concerned, I think we went over this a little bit last Wednesday. I think we actually spent most of the class going over this last Wednesday, and then Monday, presumably, you guys went over it again, I guess. Anyway, um, the numbers are going to be here now, which is going to make things easier. So average passenger weight, we're looking at about 170 pounds. And then on average, person brings about 20 pounds worth of luggage with them. So on average, passenger plus luggage is 190 pounds per person. So if we have two passengers, we're going to have to multiply that by two, which is going to be 380 pounds. Yeah, 380 pounds. And then from there, you can figure out the gross airplane weight, which is the total payload weight, um, divided by 30. So divided by 0.3. So it's going to be more than, I don't know, that's off by a power of 10. But basically multiply it by a little bit more than 3, and you'll get your gross airplane weight. Which is empty airplane weight plus payload weight plus fuel weight. And that's just sort of a rule of thumb, if you guys remember. That's not 100% set in stone going to be totally accurate, but that tends to be a pretty good estimation of the values that you're looking for. So then doing that will give you the gross airplane weight. Then from there, you can figure out the wing loading. The wing loading is, well, it's a little bit more complicated. Take the cube root of the gross airplane weight, whatever it is. Probably going to be somewhere in the vicinity of 1,300 to 1,400 pounds. Take the cube root of that, subtract 6 from it, and multiply it by 2.24. What's up with the what? This is all stuff that we've gone over the last couple of lessons, though. Finding out all these values. What I'm basically walking through right now is how to get, given the information that we started with, how to get sort of all of the different parts of a plane. It's a bit of a review right now, so I realize I'm going a little bit fast for it. But I think Wednesday, actually, last Wednesday, so that recording should be up. I spent time going over how or why exactly all these things are. Well, I just sort of go over it a little bit more slowly, I suppose. So that might be helpful. But essentially, what we're doing is we're determining all of the different aspects of the airplane given some starting values. So given the aspect ratio and the number of passengers and the desired horsepower of the engine, we can determine the size of the wings, how much fuel it's going to take, how much range it's going to have, and stuff like that. So that's what we're working out right now. Okay, so yeah, we start out with you get the gross weight of the plane by multiplying the passenger weight, the total passenger weight, which is the average passenger weight, which is 190 pounds by 3, or excuse me, 2, since we have 2 passengers, which is what, 380 pounds. You divide that by 0.3 in order to get the gross airplane weight. The gross airplane weight, using that, and this equation right here, gives us the wing loading, which is the how much weight each square foot of wing has to lift. So that one's a little bit more complex. We take the gross weight, we take the cube root of it. It's like the square root, but by the power of 3 instead of the power of 2. The cube root of it, subtract 6 from that value, and multiply it by 2.24. Okay, so we got how many people here missed the lesson on last Wednesday? No, divided by 0.3, not times 0.3. Also, that's for one passenger. You'd have to multiply it by 2 first so that you had 2 passengers. All right, let's just, why don't we just do this? I'll do this along with you guys. So let me pull up the calculator. All righty. So, average passenger plus luggage is 190 pounds, right? We want to be able to take 2 passengers. So that gives us 380 pounds. I'll pull up my notes over here as well. So total passenger plus luggage weight is 380. Then we divide it by 0.3. Math's a little bit off there, Aiden. You multiplied one of the values by 10 and then divided the other one by 10. regardless, so 380 divided by 0.3 gives you 1,267 pounds. So gross weight is 1,267 pounds. We'll just keep it at whole numbers. So that gives us the gross weight of our plane. Because when you divide by a fraction, it's the same thing as multiplying by a whole number. Like 2 divided by 0.5 is going to give us 4. Oops. All right, so we've got our gross weight of 1,267 pounds, right? Let's figure out the wing loading. So we've got 1,267. Same difference, rounding. I rounded up. So we got 1,267. We're going to take the cube root of that. And actually, on the Windows calculator, there's a button for that. But if you don't have a button, you might have one that's Y, and then it's got the little square root symbol and an X. You can hit that one and see how it says up here, 1,267 Y root. Just type in 3. Hit enter. And what that will do is that will give you the cube root. So now that we've gotten the cube root of it, which is 10.82, blah, blah, blah. So this value to the third power will give us about 1,267. We subtract 6 from this, which gives us 4.82, blah, 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 blah. And we multiply it by 2.24. Let's say it gives us 10.8. So our standard wing loading is 10.8 pounds per square foot. We don't really need to worry about the low wing loading range. That's not too bad. That's just, if you want to get a range of wing loading for the plane, then you can calculate that, but that's not strictly speaking necessary. So the gross airplane weight we already got was 1,267 pounds. The wing load range was 10.8 pounds. Now the wing area is going to be the gross airplane weight divided by the wing loading, right? Because if we've got the weight of the plane and we've got how many pounds per square foot that the plane's wings support, that gives us how many square feet of wings. So let's go ahead and do that. So we've got, 1,267 divided by 10.8, which leaves us with a wing area of 117.3 square feet. So we got some decently small wings. Not really small, but they're certainly smaller than the example plane. So in order to find out the wingspan, we need to have the aspect ratio. We know that the aspect ratio is between 6 and 8 based on the values that we were given. So we can do, why don't we do an aspect ratio of 7? Just split the difference. So we got a wing area of 117 feet and an aspect ratio of 7. The wingspan is going to be the wing area times the aspect ratio, and then you take the square root of it. Again, this is just another rule of thumb. That's kind of the annoying thing about plane design, is there are a lot of rules of thumb that were sort of determined from just like making bunches of planes that worked and figuring out the relationships between everything. So it makes it easier for us to be able to calculate this stuff, but like knowing the why, sometimes it's not really satisfactory always to hear like, well, it's because it's how it is. But that's what I got for you right now, unfortunately, because I don't know enough about airplane design to tell you exactly why. But let's see, 117.3. We'll multiply it by the aspect ratio of 7, and then we'll take the square root of it, which gives us a wingspan of 28.65 feet. 28.7 feet. And then the chord is simply the wing area divided by the wingspan. So if we take 117.3 and divide it by 28.7, because if an area is length times width, we just figured out the length, now we need to figure out the width, which is the chord. The chord is 4.1 feet. So we've got our wing dimensions, our wing loading, and our weight. And eventually from our weight, we'll be able to determine fuel, and using our horsepower, we'll be able to use that and the fuel in order to determine range. So let's see here. We already know our thrust horsepower is 250. Our rated horsepower is going to be thrust horsepower divided by 0.75, or yeah, okay. So 250, whoops, I should actually put that into the calculator. 250 divided by 0.75. That doesn't seem right. Yeah, that's backwards. 250 times 0.75. 187.5 thrust rated horsepower. So we got 187.5 horsepower for rated horsepower. Now we've got, in order to calculate the range, we've got our gross airplane weight, and the total fuel available is going to be the gross airplane weight times, well, it's going to be 15% of the gross airplane weight. It's not times 0.15. Yeah, it is. It's times 0.15. Jeez. Sorry, I'm apparently all over the map right now. So 1267 times 0.15 gives us a fuel weight of 190.1 pounds. So now we've got a fuel weight of 190.1 pounds. We already got our payload weight. So our empty weight is going to be the gross weight minus the weight of the fuel and the weight of the passengers, which we don't really need to calculate, but we can. So 1267 minus 380 minus 190, oops, plus 19 minus 190.1. So our plane is going to be super light. It's going to be 700 pounds, roughly. Our range, however, is going to be the total fuel available, which is going to be our fuel weight, times the cruise speed. It's going to be how fast it can go. We'll say it goes 150 knots. We don't really get that information, but we can just keep the same one. Divided by the specific fuel consumption, which is something else we're given, 0.5 pounds per horsepower, and times the thrust horsepower. So let's go ahead and do some calculations on that. Oh my God. Goodness. All right. So total fuel available is going to be 190.1 pounds times the cruise speed of 150 knots, which is going to be 28515. And then this is all going to be over the values on the bottom, which is specific fuel consumption, 0.5, times thrust horsepower, which is 187.5, which is over 93.75. So now let's take 28515 and divide it by 93.75. We have a range of 304.2 nautical miles. And we can fiddle with that too. You know, we can increase the amount of horsepower that the plane has. So we can, well, excuse me, we can increase the cruise speed that the plane has in order to decrease the range but have a faster plane, stuff like that. So those values can be tweaked as needed. Anyway, I realized that we went through that pretty quickly, very quickly, in fact. I just wanted to get it done before 8 o'clock. But what I'm going to do right now is I'm going to go ahead and do the poll questions, and then we'll leave it open for just a little bit of a question and answer time, and then I'll have to shove off and do the high school class. But anyway, once the poll questions are done, if you have any questions, I'm here for the next couple of minutes at least. Otherwise, you're more than welcome to head out and have a wonderful weekend.